So I'm guessing Superintendent Chalmers' major was education, but was his minor astronomy? Let's talk about it. Hi, I'm Mike Siegel. I'm an astrophysicist. I write for Ordinary Times, and this is The Throughput. So unless you're living in a cave, you may have noticed that we had a huge outbreak of aurorae last week. We had a G9 solar storm on Friday. That is a really powerful geomagnetic storm. And there were aurorae reported all over the world, from the UK to Rome to Australia to South Carolina, all over the world. That is kind of unusual to see that kind of aurorae. Now, I did not personally see them because it was completely cloudy here in Pennsylvania. I'm sad about that. I have seen the aurorae once. We had very faint green aurorae when I was at school in Minnesota. When this broke, a lot of people were talking about what aurorae are, and especially there was a lot of attention that suddenly came upon a scene from The Simpsons where Superintendent Chalmers questioned Seymour Skinner about the reality of an aurora that's confined to his kitchen. We'll get to that quote in a moment, but let's talk for a minute about what aurorae are. Now, let's say for a moment that this basketball is the sun. The sun, like the Earth, has a magnetic field. But unlike the Earth, the sun is a super hot ball of plasma at 5,800 degrees. And so there are many things that result from that. One of which is that the sun creates this flow of charged particles that go out into the solar system that we call the solar wind. And this is a constant flow of particles from the surface of the sun, of hot energized particles, especially from the corona that is above it, that is very hot and luminous, that sends out these streams of charged particles into the solar system. Now, these particles would be dangerous to the Earth, but we are protected by our own magnetic field, which acts as a sort of deflector shield. These charged particles come in and they sort of are directed around the Earth for the most part. Let's just say that my iPhone cord here represents a magnetic field line flowing through the sun. There are two things that make the sun unique and very different from the Earth. That is that it's a plasma. And so what happens to the magnetic field is it gets a thing that we call the frozen in condition. These parts of the magnetic field get locked in to certain chunks of plasma within the sun. And so they can't, just freely move around like they can in a conductor or something like that. The sun also, because it's plasma, rotates what we call differentially. So the plasma at the equator of the sun right here is moving faster than the plasma at the poles of the sun. And so what that tends to do is you have this magnetic field locked in, and over time it begins to stretch out. This part of the sun in the middle is rotating a little faster, and so the magnetic field is being stretched out and stretched out as time goes on. Over time, the magnetic field of the sun has become more and more tangled inside the sun. Instead of having these beautiful patterns that you will see in textbooks, it's a chaotic mess inside the sun. And as time goes on, what happens is those magnetic field lines begin to poke out through the surface of the sun. Where they do, the surface of the sun gets colder, where those magnetic lines flow out and in, and those are sunspots. They are a few hundred degrees cooler than the rest of the sun, so when we look at the sun, they look dark compared to the rest of the sun. And you can actually see solar prominences sometimes where you have the magnetic field line coming out and you have plasma flowing along this magnetic field line. So you can actually see the magnetic field, like if you've ever done iron filings with a magnet, same thing, that you have this plasma flowing along this magnetic field line. Well, eventually that magnetic field line is going to stretch out until it snaps. When that happens, that is called a coronal mass ejection. And what happens is the sun then throws out an enormous amount of material into the solar system. It's like that solar wind burped, and it just sends out a huge wave of plasma into the solar system. I'm showing you videos now from the SOHO satellite, which caught one of these coronal mass ejections, and you can just see from the scale how huge these things are. It only goes out in one direction, so it may not be directed at the Earth. But if it is, what's going to happen is it's going to come in and strike our magnetic field. A lot of it will be deflected away, but it's so powerful, some of it will overwhelm the Earth's magnetic field and come in and start hitting the Earth at the north and south poles of the Earth. And that's what we call aurorae. Those charged particles come in, they strike the atmosphere, they excite molecular oxygen and molecular nitrogen. Those molecules jump up to higher energy levels and they drop back down and they emit light in certain colors like purple and green and blue, and that is what we associate with the aurora. Now, most of the time when you see aurorae, they're just confined to the poles, to the North Pole where you call it Aurora Borealis, or to the South Pole where you call it Aurora Australis. But right now we are at a time what we call solar maximum. The sun goes through this 11-year cycle where it increases in activity and then slowly decreases in activity. The magnetic field gets more and more tangled up inside the sun. That's breaking through. It's creating more of these sunspots. It's creating more of these coronal mass ejections. But then it sort of dissipates, reverses. The sun goes quiet, and the magnetic field starts forming again, and then the cycle starts all over again. We're at solar maximum now, so we're getting hit. This is the second time this year we've gotten hit by a geomagnetic storm. They vary in power. This was the most powerful we'd had since 2003. And so the more powerful it is, the further south those aurorae are going to get. Normally, they're just confined to the northern and southern regions, but they extend further and further south or further and further north, depending on how powerful they are. Now, the Aurora Borealis gets more attention because if you look at the Earth, if you look especially north of the 45-degree line right here, you see a lot of places. You see Russia, you see parts of Europe, you see Scandinavia, you see Canada, you see Alaska. Whereas if you look at where the Aurora Australis is seeing, you don't see a lot of land. You have New Zealand, Chile, Argentina, and that's pretty much it south of the 45th parallel. So the Aurora Australis is just as powerful. It's just not seen as many because fewer people live where they can see it. So what happened this weekend was we had a very powerful geomagnetic storm, and the aurorae came pretty far south, down to Italy, South Carolina over here. The Aurora Australis was seen in Victoria and in New Zealand and in Tasmania. So, that's a pretty powerful storm to get that far north and south. Now, there is a downside to this. You have this enormous flow of charged particles. That's going to start inducing currents in electrical wires. In 1859, we had a massive coronal mass ejection called the Carrington event. When it hit the Earth, there were aurorae seen as far south as Cuba. But what happened to the telegraph wires was astonishing, that you had sparks leaping off of them. You had people able to send telegraph messages with their batteries disconnected, just using the current that was flowing through the wire, induced by that change in the magnetic field. There were fires started because of sparks leaping off of telegraph machines. And in 1989, we had a big storm that knocked out power to Quebec for like 8 hours because it can induce these currents in the electrical grid, which can overpower and explode transformers. And there's especially worry about the really big transformers that are major parts of our power grid, that if they were knocked out, you'd be talking about thousands or millions of people losing power, possibly for weeks or months. And you can imagine if that happened in the winter, it'd be very bad. It's also very bad for satellites. I work for Swift. Over the last year, we have lost about 20 kilometers in our altitude, our orbital altitude, because during solar maximum, the Earth's atmosphere is being stimulated by the sun. It gets thicker. That increases the drag on the satellite. Even though we're 550 kilometers up, we're about 500 now, there's still a little bit of atmosphere that's creating a drag that will eventually return Swift and Hubble and other things that are in low Earth orbit to the surface of the Earth. With this big solar storm, it may be a while before we know the effects, but it's probably going to cause a lot of satellites, including Swift and Hubble, to drop a bit. They can also be just fried by it because they are less protected when they are up there in space than they are on the surface of the Earth. There is a very real danger that if something like the Carrington event were to happen right now, you would be talking about global power outages. You would be talking about the GPS system being potentially knocked out. You'd be talking about a lot of satellites being fried. You would be talking about, especially with this Starlink system, which has thousands of satellites out there, you'd be talking about potentially dead satellites out there colliding with each other, creating more debris, potentially creating Kessler syndrome, where there's so much debris you lose the ability to launch things into space. It could be a disaster. The thing is, It's not a matter of if a Carrington event is going to happen. It's a matter of when it's going to happen. It is inevitable. Last 2 solar cycles ago, the sun had a Carrington-style event, a coronal mass ejection that was that huge and missed the Earth by a few days. It was just pointed slightly in the wrong direction. But there are things we can do. We can harden our grid. We can have transformers on standby to replace existing parts. We can have satellites ready to launch to replace existing ones that are fried. One of the things we could do is, if we will get several days warning, we had some warning that this geomagnetic storm was going to hit us, we could just shut down the power grid. That would take an enormous amount of coordination. And I'm sure someone in the comments will tell me why it's not really that practical. But that would be one way to just disconnect everything, so that when currents flow or are induced through the electrical system, they aren't frying everything out. So the Carrington event is a disaster that will hit us at some point, but it is a preventable disaster. And it would cost a fair amount of money, billions of dollars, to harden our grid and to have the backup systems necessary to ride one out. But considering the trillions of dollars of damage that a Carrington event could do, I think it's kind of worth it. Earth is not the only planet that experiences aurorae, by the way. We have seen them on Jupiter and Saturn and Uranus and Neptune. Any planet that has a magnetic field in the atmosphere is going to have aurorae. So that's what aurorae are. If you did see it, I am jealous of you. If you do hear of another one, really make the time to go out and see it. Between 10 p.m. and 2 a.m. is probably the best time to see it wherever you are. The strength of a geomagnetic storm can vary dramatically over short periods of time, maybe 30 minutes to an hour. So there are space weather feeds on Twitter and other places that will tell you where we are, what kind of storm we're experiencing, whether we should be experiencing aurorae. And if you do hear of one going out and it's in those times, go out and look at it, because it is a magnificent thing. And people said the pictures don't convey how eerie and impressive it was. And so I'm hoping that I'll see one at some point. But on the other hand, I'm kind of hoping I won't, because that means that my satellite may have dropped another few meters. So it's a mixed bag. Anyway, the one thing that was kind of amusing this weekend for me as a Simpsons fan was that there was this clip from the 22 short films about Springfield went viral. And we're going to talk about it.
Good Lord, what is happening in there?
Aurora Borealis?
Aurora Borealis. At this time of year, at this time of day, in this part of the country, localized entirely within your kitchen.
Yes.
That's it?
No.
I think one of the things that's being told here is that Superintendent Chalmers minored in astronomy, because he clearly understands. He does mess up. He says at this time of year. Aurorae can occur at any time of year, so that's really irrelevant. But he says at this time of year, at this time of day, aurorae are really bright in the night sky, but they are too faint to see during the day. So it would be an extraordinary event if you saw them during the day. He says in this part of the country, the writers have always played a little game where Springfield is in different parts of the country, depending on what kind of story they're telling. But unless Springfield is in Alaska or something like that, it'd be very rare to see an aurora there. And then he says, confined entirely within your kitchen. Aurorae, as magnificent as they look, one of the reasons they are so impressive is because these are tens or hundreds of kilometers up in the atmosphere. You're seeing them from a great distance. And that's one of the reasons they are so impressive, that they are visible to the naked eye at that distance. So you would not have one confined entirely within your kitchen. If you did have an aurora in your kitchen, then we've been hit by a solar flare so powerful it's going to make life extinct on Earth. So maybe that's what his concern is here with Principal Skinner. He does mess up about it can be at any time of year. So that's why I don't think he was an astronomy major. But astronomy minors are pretty popular, especially on our campus at Penn State, because we really enjoy teaching intro astronomy. So well done, Principal Chalmers. I think you really called him out here. Unfortunately, when he said yes, you were so fascinated by the idea of an aurora, you didn't dropped all your skepticism and asked to see it. So that's aurorae. That's the Great Solar Storm of 2024. I'm editing episode 5 of Three Body Problem now. I have a grant proposal due in a couple days. That's why it's probably going to be a little bit delayed. And also my birthday's this week, so that's going to be a little bit of delay, but I'll get that out as soon as I can. But until we talk again, I'm Mike Siegel. I write for Ordinary Times. Thank you for watching.